What's going on YouTube? This is IPSA. I'll be doing Skyfall from HackTheBox, which is very challenging because of all the new techniques and technologies that really forces you to up your recon game because there's a ton of recon going on here. It starts off with a Flask app running behind NGINX. As you're poking at the app, you discover there's two 403s, one delivered by the Flask app, the other NGINX. In this scenario, there's a URL parsing bug thanks to WERKZEUG running strip on tons of fields in the header, which ultimately lets you bypass the NGINX denylist and access the Flask page, which leaks information about an out-of-date MinIO instance, which is like a cloud storage service that supports versioning of files. And there's an old copy of bashrc if you look at the versions, and this contains a Hashicorp Vault API key, which if you do some enumeration, you discover it provides you a one-time password to SSH. Here, you can run a sudo command, which writes files that are only readable by root to your current working directory. We can use libfuse to create this weird virtual directory mount, which will log all writes in that directory to a file, which we can still read even though root wrote it. So I know it's a lot, so I'm going to jump in. As always, we're going to start off with an nmap, so -sc for default scripts, SV, enumerate versions, -vv for double verbose. This gives us the TTL, OA, output all formats, put in the nmap directory and call it Skyfall, then the IP address of 10.10.11.254. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open. The first one is SSH on port 22, and its banner tells us it's an Ubuntu server. We also have HTTP on port 80. Its banner tells us it's NGINX, also running on Ubuntu. And the title of the page is Skyfall, Introducing Sky Storage. So let's just go ahead and take a look at the page. So 10.10.11.254. And we can see what this page is. We have their dedicated team bringing you the future of data management with Sky Storage. So it looks like some type of cloud company. Now, the first thing I'd probably do is try to figure out what this is built with. I like looking at 404 pages. A lot of just languages will have a fingerprintable one. This is giving us just an NGINX thing, so no real information there. We can check PHP, HTML. That is the page. We can also send it to Burp Suite and see if anything is in the headers. Maybe there's like a cookie that would expose what it is. So let's just go take a look. And let's just send that to repeater and nothing. So I'm guessing this is just a static website. Maybe it's something more, but we can't really figure out what this is built with just yet. We could also look, I guess, at the HTML that came back to see if we saw like links to WordPress or things like that, but my other recon probably would have pointed that out as well. This HTML is odd how it's like stacked on top of each other. That may be, nope, I thought it was maybe because I zoomed in or something like that. Just glancing out the page, this link goes to demo.skyfall.htb. So before I click that, I'm just going to add it into my host file because we don't have DNS in this lab. So whenever there's links that go to HTTP domains, you have to add them. I'm also going to add skyfall.htb just so we have it in case anything links back to it. Clicking the try the demo. We have a few names. James Bond is the CEO. Aurora Sky is the developer. And Bill Tanner is the chief technology officer. There is a contact form as well we could play with. Looking at the login, it gives us demo credentials. So we can try guest and guest. And we get logged in. So the first thing I notice is it's powered by Flask. So we're dealing with a Flask web app. We have this dashboard. Nothing here looks clickable. So let's just go take a look at what we can do. Clicking on files, it looks like there is a welcome.pdf. So I'm going to try downloading this. So let's go download. And looking at it, oddly enough, it gives us the file name. So whenever I see something like this, I'm going to try like a LFI. So we're going to do a bunch of .. slashes and then etc passwd to see if we can retrieve it. And we can't. We just get redirected. It was what? Welcome.pdf. We could also try // and this also redirects. If it was a file open, normally // works. So chances are this is not just a standard file open type of thing. Looking at this cookie, this doesn't look like it's base 64. I don't know exactly how this is. Let's see. Echo. It's probably some type of Flask cookie, right? Not base 64 input. So don't know how that's generated, but it doesn't look like a Flask cookie that I'm used to seeing or a JWT. Not sure what that session is. Let's see. If I had to guess, it's probably from like a Python library called It's Secure or something, just because it doesn't look like a normal Flask cookie, and that's normally what I'm used to seeing. Or maybe It's Dangerous. I forget exactly what library it is that I'm used to seeing Python use a lot. We can try uploading a file if we wanted to. Let's see. Let's, I guess, try this. I'm just going to upload this license, see what happens. We are intercepting. So we can forward that request. We can look at the upload. Let's see. I'm going to put dot slashes there, see what happens. And, oh, that's us accessing the welcome. Let's see. It got rid of all my dot slashes. So there is some type of like stripping in play there. There is rename functionality on things we download. So we can try like a dot slashes here to see if that does anything. Intercept is off. And it looks like it stripped anything there. And I guess we could try like brute forcing potential file names. That's like the only thing left. But I'm going to move on to the next thing. Let's go to beta. And the reason why, if it was like UIDs or things like that, I would definitely brute force, but based upon file name, I'm not just doing it on that in general. It's probably going into like a guest directory or some type of database that ties it with my username, since I can only see my files. So let's see. That is what we had downloaded. Beta features. This is a 403 forbidden. URL fetch. What happens if we do HTTP 127.0.0.1? Download. We get an error message that looks like it came from request. And it says it can't connect to 127.0.0.1 on port 80. So let's try HTTP 127.0.0.1. Let's do it the IP address, 10.10.11.254. Click download. It says upload succeeded. I don't know where it went. Maybe it downloaded to my files. It did. So we could download this and see what it looks like. Sure. Less downloads 10. And we have the page. So it looks like we have some type of server-side request forgery right now. I'm going to stand up a netcat listener. We'll try to fetch against myself. So we can do HTTP 10.10.14.8 8000. We see it is indeed Python request. The other thing I guess we could do is try to figure out why 127.0.0.1 didn't work. I'm going to guess it's because of this is probably running in a Docker, and maybe the website isn't running on port 80, right? So the first thing I want to do is just see if I can get non-HTTP data. So I'm going to get localhost SSH. And we see connection aborted, so we see the SSH banner. So that's somewhat good. This lets us easily enumerate ports. So what I'm going to do is make a request to 127.0.0.1. I'm going to put fuzz there because I want to eventually get this entire request into FFUF. So I'm going to grab this. Then we can copy to file. And I'm going to name this SSRF.request. And now we can use FFUF. So FFUF-request SSRF request proto HTTP word list. Let's do every port. So 1 through 65,535, I think. Okay. And we need to do some type of filter. So I'm going to do filter regex. And then we want to get something that does not work, right? So let's go back here. Take that off. Let's see. HTTP. We can just do 127.0.0.1. This will give us the error message. And I'm going to do error number 111. We could do like connection refused or anything like that, but this should work. Looking good. The one thing I want to test real quick is I wanted to have a known good. So I'm going to change this 127.0.0.1 temporarily. We're going to do 10, 10, 11, what was it? 254. There we go. So now we know this does indeed work. I probably should have renamed that. 270.0.0.1. And if you don't know, FFUF is going to go and look at this request, and wherever the word fuzz is, that's where it puts the item in a word list, right? So that's how that's working. But this will tell us what ports are listening on this Docker container, if that's why we can't get to 127.0.0.1. So now that I have that going, let's go to the next thing. We get a NGINX forbidden. So it's odd that we have two different 403s right now. So we have a 403 from definitely the web server right here when we go to beta. But when we do the /metrics, we get a 403 from NGINX. So if we can make this server-side request forgery work, it's possible that we'll be able to bypass the NGINX rule because NGINX is in play. I'm guessing, let's see, we can draw this out real quick while we wait. My client goes over to, let's do it in V. So my client is making a request to NGINX. NGINX says, oh, 10.10.14.8, I'm going to, let's see, deny if from 10.10.14.8 and request is /metrics, right? That's kind of what I think is happening, right? Other than allow if not. So if this SSRF does work, then we'll be able to hit /metrics because we'll be coming from 127.0.0.1. And additionally, we'll be on the container. So let's see, it doesn't go to allow. Send to Flask if not, right? So if I can access Flask directly, then I'll be able to bypass NGINX altogether. That is my thought process right now. And we see 5005 comes back. So let's take a look at what this is. So if we do HTTP 127.0.0.1 5005, hit download, it's going to say upload succeeded. If we go back to files, let's see, we have one here. We can download it. Yes. Let's save that. And we can do less downloads 127. And I think this is it. Demo? Maybe not. Because the word demo does not appear. Oh, demo login, guest. So this is definitely the page. So let's try having this fetch on metrics. So we can do HTTP 127.0.0.1 5005 /metrics. And it does not work. We get a unable to download file. So that doesn't work. There is something else we could potentially do. And it's going to be kind of like that Tomcat one, right? Where we make a request. Let's see if I can go here. Our request is not going to be metrics. It's going to be, like if this was Tomcat, let's say, if this was Tomcat, we would make a request to like /... metrics, because NGINX would say, oh, the request is no longer metrics, so I'm going to allow it. And then we get to Tomcat, it's going to remove this because it treats like ... as a directory traversal. So it just removes that and says, okay, here's metrics. So that's how you can bypass if it was running on Tomcat. Now, Python is a little bit different. If we go to hack tricks, hack Flask, this gets us to a blog post that we want to see. So let's see, going over here. And it's a very, very subtle thing. So let's see, where is that blog post? It's this, the Flask proxy to SSRF. we're not pre-pending a @ sign. If we go to the write-up, it gives us other examples. So this post talks about NGINX ACL. So this is what it is. The location/metrics deny all. And then Python is calling trim, or it's probably going to be strip actually. And Flask uses WERKZEUG, that WERKZEUG, I forget how to pronounce it. But if you look at the WERKZEUG library, it calls strip all over the place. A lot of people think strip will just remove things like spaces and new lines, but in Python, it does remove quite a bit more. We could look at the C Python code and like trace it that way, but it is surprisingly not that easy to do. MinIO XDF had spent like 30 minutes tracing it. It's much easier just to show by demo, right? So I'm going to loop over 256. So this is going to get me every single like potential byte, right? So get 00 to FF. So we're going to make that into a char like this. And now I'm going to say if the length of this dot strip is equal to 0, then we can print. Let's see. I guess I'll just do byte 0 to x was stripped. So if we run this, it's going to show us every time the strip call erased the byte, right? So if we do Python 3 test.py, we can see 0 day, 09, 0a, 0b, 0c, 0d. If we look at ManASCII, it will make sense why it's stripping those, right? So let's go with 09. 09, that's going to be a horizontal tab. 0a is a new line. This one's not a surprise. That's what most people use strip for. 0b is going to be a vertical tab. 0c is a form feed. 0d is a carriage return. Then you got a bunch of others like 1c is going to be a file separator. These two are not part of ASCII. It's like Windows things. I forget exactly what these characters are. If you go to like ChatGPT, it would say 20 space. But these are everything that strips out. So what we want to do is make a request, and NGINX is going to pass the request along because it doesn't match /metrics. And then when Flask gets it, Flask is going to strip that character, and suddenly we'll get a page. So that is what the goal is. So if we go metrics A, we just get A404 not found. I'm going to go into hex. We're going to go to where the A is in my metrics, right here. And then we're going to go here and go down the list. So I'm going to put 09. So if we do 09, we'll see what happens here. Looks like we get a page right away. So we put a, what was that in it? 09, a horizontal tab. We put a horizontal tab, and it looks like that allowed us to bypass. So let's go take a look at what the page actually looks like. Let's go proxy. I'm going to do it here. I think I was 09. I did. Send it. And we get this MinIO internal metrics page. Again, what is happening is we're sending a request, and our request has metrics, then \x09. NGINX just processes this entire thing and says, yep, I don't have a rule for that. I'm going to pass it on. And then when Flask gets it, Flask calls strip, it removes it, and then sends us to the /metrics route, not giving us that hex character at the end. So that is a fun little bypass with like Flask behind NGINX. And then looking at this, we have MinIO, and MinIO is, I don't know exactly what it is, a good way to explain it. It's like allows us accessing a file system like S3 and Kubernetes, object storage system, whatever, right? So looking at this, we get the MinIO version right here. And we also get another URL. we have the location of where MinIO is. That's at prod 23 S3 backend. So it looks like this is going to be something related to file storage. So Skyfall, the cloud storage company, is just using S3, and it's using MinIO to access the files off of it, right? So let's see. Let's go into my host file again, not passwd. And I'm going to add the Skyfall HDB. And we can also look at the MinIO version. So I'm going to grab this. Oddly enough, the version is like a date, it looks like. This is the host name, and this is the 9000 is the port it's running on. So it looks like it's a cluster. But if we do MinIO exploit, put in that version, which is a date string, so odd. We go to this MinIO blog. And it talks about 2 different CVEs. And I don't see anything too interesting. If we Google this CVE, let's see, do we get anything? Sentinel-1, an information disclosure vulnerability. So it looks like if we make a post request to MinIO bootstrap v1 verify, it'll give us some information. So let's try this out. I'm going to go back here. If I could just go here, we can open this link. This is the metric cluster. We actually want, what was it? MinIO v1. And then what? MinIO bootstrap v1 verify. Bootstrap v1 verify. And it was a post request. So we want to send it to burp. Let's get off of raw. So we do the get. Access control has been disabled. Change that get to a post. And suddenly, we have a bunch of information. So what I want to do is copy as curl command so we can easily save this. There we go. I don't want it to save everything. Let's see. I'm going to call this minio.json. For some reason, I put the HTTP headers in. It's probably one of the curl arguments. There we go. We can cat this jq dot, and we get a MinIO root user, MinIO root password. So if we grab the MinIO client, we can then start interacting with this directly. So if I just do MinIO client, maybe, to download this, let's see. We probably have to turn burp suite off. Proxy, sure. There we go, this MC client. Simple, fast, go to download. Let's see, MinIO client. This is definitely what I want. AMD. Where's download? Linux. There we go. KMS, catalog, binary. This looks good. So we can wget this. And that says we do a chmod plus x and then alias set the name, URL, username, password. So once this finishes downloading, we can set it. Suddenly started going really slow. I'm going to try another wget real quick. Okay. Let's move mc.1 to mc. chmod plus x, mc. Okay. So it wants alias set. I'm going to call it Skyfall. Then we have to give it the URL. So we'll do HTTP. Let's go here, grab this. and then the username and password. So let's cat this, jq dot. Username, probably this, and password. Alias has been set successfully. So if we do MinIO help, we can see what type of things we can do. There is a ls command to list the buckets and objects. So if we do mcls, we probably have to specify Skyfall. We can see there's a bucket for every user. So if we do Skyfall guest, maybe it's just Skyfall/guest like that. We can list the files in the guest bucket. So this is why we couldn't do LFI, because we were accessing a like S3 file system. When we do .. Nothing worked. The thing I'm curious about is I wonder if we could have, if we knew we were dealing with buckets and usernames, if we could download from other people's directories. So let's go back here. Not that this really helps us with anything at all, but it is interesting. So askyy. Let's do welcome.pdf. No, we can't. So we can't escape the bucket through some type of LFI or file disclosure, not LFI. Let's see. If we look at ls, there is two things that stand out. We have recursive, so we can list everything. And then we also have versions. So if we do a ls -r for recursive and then Skyfall, it's going to list everything. There's also versions. So I'm going to add versions to this. And we have multiple versions of this home backup from askyy. So I want to download each of these. I'm going to download v3, v2, v1, and look at them. So we probably want that cp command we saw earlier. And then to specify the version, we specify -- version ID or VID. And then source and target. So let's go /mc -vid. What do we want? Let's grab v3 first. I'm going to go grab that. And then we want askyy home backup. And then I'm going to call this v3.tar.gz. Was it --vid? I need CP. And we need Skyfall. There we go. So we got v3. I'm going to get v2. So we can grab that. Let's delete the VID. Put this at v2. And I'm going to copy v1 right now so we can download that right after this. So delete this. Paste that. So we have the three versions. So let's make dir askyy move all the v's here. tar xvf v1. Let's see. It has a bunch of dot files. So actually, and delete that. We do this. Please don't delete all the v's. Sweet. Make dir v1, make dir v2, 3. Let's just untar each of these. So now we can look at all the files. So if we do ls-la on v1, actually let's use find, type f. We can see there's a bunch of Terraform stuff. So if we look at Terraform, let's see. I look at package.json to see what this is. Terraform, Hashicorp. Don't know. Let's see. grep-r password. That's in README. Secret. Let's see. Variable. So right now I'm looking for any type of secret that may be in this Terraform file. And I don't really see anything. So I'm going to move on to other things real quick. There is a bash history that has content. So if we look at it, there is a bunch of files or a bunch of commands being ran, but nothing really stands out. I'm not going to go through all of this because it's quite a long history, but nothing really looked interesting to me. So the next thing I want to do, see what's in V2, V3. We got SSH. V2 SSH. Authorized keys. Do we have any IDRSAs? V3 SSH. V1. We do in V1. So let's cat idrsa.pub. This is askyy. So I'm going to chmod 600 idrsa. And we're going to try to SSH with this key. So askyy at 10.10.11.254. And it doesn't work. So let's see. Let's see all the unique files here, because there was a bunch of like bash history. Like all those files, are they the same or not? Instead of manually looking at them, I'm just going to do a find type f, and then we can say xargs md5 sum, do md5 sum every file, or is it exec? There we go. I'm going to pipe it over to sed real quick, and I'm going to remove the v3. Then we can sort unique-c, sort this again. Okay. So these files are the same across everyone. SH authorized keys, bash history is 2. So there's one unique history. There's also one unique bashrc. So these are the two that I want to take a look at. So let's look at bashrc. I'm going to do a diff on v1 .bashrc and v2 bashrc. And one of them has this Vault API address, and it gives us a new URL. So let's go ahead and add this. So we can do sudo v etc host, and then we can add that. And what I'm going to do is curl this, and we get a 404 not found. I'm going to do a -v to see if it leaks exactly what it is. Doesn't look like it does. So I can't see what Vault is. If we Google what Vault token, so let's just Google this. Vault token. We get a bunch of stuff about Hashicorp. So this is probably going to be a Hashicorp Vault. So let's see. Let's say Hashicorp Vault Client. See if we can access it or get information. Vault Client Go. This may be good. Releases. I don't have a binary. Am I going to have to build this? Installation, go get. Let's see. Go mod. I'm going to see if I can just compile this real quick. I'm sure there's a compiled binary somewhere. Go build. Let's see. Package maps not in Go root. Something is odd here. Vault client download. This is probably the right page. Brew install. Do I really have to download this from apt? Oh, binary download. That's Mac, Windows, Linux, AMD 64. Here we go. So let's get rid of that and then just wget, unzip, chmod plus x vault. And let's see. We probably want to export those variables it had. So let's go with, where's that diff command? See, I was in askyy, diff. Let's just run these. Because I'm guessing the vault binary is going to use these token values. So if I execute vault now, let's see, we can do vault, token, lookup, and let's see, vault address not found. So maybe it's not vault API address, maybe it's just vault address. And this confirms that we're talking with a Hashicorp Vault instance. And a lot of this next piece took me a really long time to find because we're in a developer group, but developer can't really do that much. If we try to do vault, let's see, if we do policy list, we get permission denied. So many things give us a permission denied. What eventually helped is finding a obscure command. Let's see. Hashicorp Vault, what paths can be accessed? Try this. And we go to this Stack Overflow page, and it talks about this command, this vault read. So if we run this command, it's going to list every capability that our user can do. This is really what I wish the vault, the last command we did, the token lookup would give, but it's not. So let's see, we have the ability to read on token lookup self. We can renew, revoke. There's this SSH cred dev OTP key role that we can create, read, and update. We can update our capabilities. Read resultant ACL, that's what we just hit. Lookup, renew. Let's see. Syspolicy developers read, renew. We can list SSH. So let us list SSH roles, right? So if we do vault and then list, we can specify, I don't know what the terminology is. Does it say the first level of path? We know SSH exists because we get no value found. If it didn't exist or it was something else, then we'd get this permission denied. And then if we look at what roles SSH has, it has the admin OTP and the dev OTP. So I'm guessing OTP is like one-time pad. And if we looked at a previous one, the OTP we have, we can create, read, and update from this. So if we look at the SSH command, we can, let's see, vault SSH. The mode is probably going to be OTP. The role is going to be the role we have, and then the user. So let's run that command and see what happens. And if you don't know, this is, I guess, kind of like a password manager type thing. It's supposed to be a secure way to store credentials. So if this works, then we'll just magically authenticate into the server. So we're going to say SSH mode is equal to OTP. Then role is going to be, was it dev OTP key role? and then the user at 10, 10, 11, 254. And we get logged in. So that's cool. Before we move forward, though, I want to take some time to kind of explain what's going on because you may be confused if this is your only experience with Hashicorp Vault. So what I'm going to do is let's proxy this real quick. So let's do HTTP proxy is equal to HTTP 127.0.0.1 so I can see what command this is doing. So I'm going to turn intercept on. We can run this. And it sends a put command to this URL. And it responds back with this. And this is actually going to be the password that is valid for one login of askyy. So if we wanted to, we could do SSH askyy at 10, 10, 11, 254. Put in this password, and then we get logged in. If I try that again, I'm guessing it's not going to work. So we'd have to send another request, grab the key, copy it, and log in. So that is what the Hashicorp Vault is doing. It's giving us a secure way to set a password. Now, if you didn't want to use the binary, you could go and manually look at their API. And this is the way, the intended way to do it, I guess, because when you go manually to the API, there's one endpoint you can hit that the binary just doesn't have. That does become a little bit useful. So if I Google Hashicorp, I'm going to go open API schema, I think. Hopefully I can find this quickly. Perverter spec, is this it? Go get. Generator config. Something told me how to pull the open API schema. I don't know exactly where that is. Oh, right here. So if we make a request to here, let's see, let's do get v1 sys open API spec. There we go. We'll get this whole open API document. So I'm going to download this real quick. Scroll. And we're actually going to use Postman to look at this. The whole reason I'm going to go grab this open API document is this is how I would normally do this, right? Because you could look at their documentation online, which would be like just a big page, and look at all the endpoints manually. But I find it very clunky because then you take the endpoint from your browser, go to Burp Suite, and then test it, right? That's not the best way to do that, right? Let's see. So I'm going to open up Postman, which is free. You do have to register, but I have it set up just to use my email, and I'm on the free account. So nothing I'm showing you is going to be paid. So I go to Workspaces. We could try to go and search for public collection. So if we Google Hashicorp, there is this workspace that online just magically has a bunch of Hashicorp things, right? So I can go to Hashicorp Vault, Management, Audit, Policy List, and this is the URL that the policy I'm trying to read with the command line client actually gets denied because we don't have access to sys policies. We can just do sys policy. So I'm going to go back real quick. Let's go back to Workspaces. I'm going to create one. Just create a blank workspace. I'm going to call this Skyfall. Create. And then we're going to import. Do I create collection? Import. And then we specify that open API file. So let's go HTTP. Oh, that's not what I want. HTTP. Skyfall. Open API.json. And let's see. Did we import it? That should have worked. Why do we not go to another page? HTTP, Skyfall. Does not recognize it. Because we errored. I'm guessing we needed to be logged in because we have an XVault token here. I'm just going to copy and paste this. Let's see. Copy the file. Open api.json. Delete these. Okay. I'm not used to like the open API schema being behind some type of login. Import it. We do OpenAPI 3.0. And then it's going to process this and give us a list of all the routes. So let's see, what was the first one we did? We hit an auth route. So if we go auth token, lookup self, accepts a GET. And we have to specify a few things in our config, the base URL, and we also have to do where we authenticate. So I'm going to go back to the top. Then we can say authorization, API key, and then let's grab the API key. So XVault token. And then here's our token. Add it to the header, save, and then the variable, the base URL. We need to grab this. And it's /v1. Okay, save this. So now when I go over here, we can send this GET, and we get the response that our binary did as well. So from here, you could see I'm in the developer group. So if we look at sys policy, and then policy accepts name. So I'm going to give it the name of developers. We send this. Permission denied. Probably because I have a capital D. There we go. So we can see what developers can do. We have a capabilities read, SSH creds dev OTP role. We could look at SSH roles. So if we go here, click on roles, let's see, we can get a role. So that was dev OTP key role, and then send that. And we get denied. Is this going to be developers? See, I wonder if we don't have to specify the exact role. If we go back here to list, okay, we can do the list. I'm not sure why we had permission denied on that role, but here we can see we have that. You could also go, what's the next one we had? We wanted to access, we can just cheat and look here. SH creds. So SSH creds, and that's a post. So this would be dev OTP key role, send. Username is not present in the allow. V1 SSH creds. That is bizarre. I'm doing a put. And this is just a post. V1 SSH creds. That's bizarre. Settings. So proxy. I know there's a way to send this to a proxy. I just don't know off the top of my head. Let's see, the body. Oh, we had to send things in the body. Missing IP. IP 10.10.11.254. There we go. If we don't specify a username, it defaults to nobody. So I don't think that's going to let us log in. sh nobody at 10.10.11.254. It does, but we don't have a shell. So I wonder if we go to the API, let's see, username. We used askyy here, right? If we do this, send, it works. Let's do root. Okay, so that's what was happening before, is because we weren't in xww form encoded, username wasn't on the allowed user list. So this dev OTP key can only generate keys for the user askyy. But the key point I've been trying to make here, though, is just generally how you go about API testing. You normally get like an open API, some type of JSON file. Maybe it'll give you a Postman file because this is commonly used by developers. And then you can go through all the individual endpoints. I would not trust any public collection because those public collections, as we showed before, may not have every single endpoint. But this is just a good way to test a bunch of endpoints manually. So hopefully you enjoyed the quick look at Postman, but we can move on with the box where we have a shell, I think. Do we do it in this window? Let's see. Yep, here it is. And if this doesn't work for you, try SSHing in, because this won't prompt you for the host key validation, right? So if I cat etsy host, demo Skyfall HTTP will go there. So if I run this command again, and we try this key is not in my allowed list. So it's not going to work, hopefully. Yeah, fail to run SSH command, exit status 6. And this is using SSH pass. So if you don't have this installed, then it'll probably prompt you for like a credential. I don't know exactly what it is, but SSH pass will exit 6 if you have a host key validation error. So if we SSH to this, accept it, then we run this command again, it'll let us in. Okay. And that's how we get user. The root, it does take a long time to find, but it is not that complicated. If we do a sudo -l, we can see we can run this vault-unseal command with this YAML file. We can't read the YAML file. We can specify the arguments v, h, and d. So if we run this, let's see, I guess we have to sudo this -c -h. It is verbose, debug, and config. So before I run this program, I want to see exactly what it is. The first thing I always do is just Google the program name. And in this case, it brings us to a GitHub repository, which seems to be what the program is based off of. I say based off of because if we look at the options here, it has a -l, the log path, and we have a -d. So this is probably modified by the creator to add that debug flag in. I looked at all the previous commits, never saw debug in this application. But what this does is it allows us to unseal a Hashicorp Vault. That's the application that we've been interacting with. When that application starts up, you have to enter the master key to unseal it. And then once it's unsealed, then you can access the things in the vault. The actual Hashicorp Vault never gives you a way to just store the secret on disk, so it just automatically unseals. In order to do that, you just have to use the API or this program, right? So let's now run this. So I'm going to go, let's go in dev shm real quick, just so I can run it in a temporary location. And we'll run it with the verbose and debug flag. And we see it reads it, finds a security risk, and that's about it. It creates this debug.log file, and it's owned by root. Now, the very first thing I try is touching the debug.log and then running it again. Because if the file already exists, there's a chance it doesn't change the owner back to root. And if that's the case, then we will read debug.log. That was not the case. So the other thing I'd check is I'm going to touch debug.log. I'm going to run a stat against it because I want to get the exact inode. Does this tell me the inode? Maybe I'm pretty low. I would not expect that. I should get another SSH session to this. Let's see. Vault SSH. We can grab this. Oh, I need to get the credentials. Do we have this? Awesome. Grab this. SH askyy at 10.10.11.254. Paste this in. Okay. Let's go to 2. I'm going to open a handle to this log file. So we can say f is equal to open debug.log read. And then before I call read, I'm going to run this again. So we can do f.read, and it's blank. If the file wasn't deleted and recreated, I believe in that case, we'd still be able to read it. And we can see the inode has changed. So we had 7 here, now it's 8. So the file was likely deleted and recreated. Now, there could be a way we could potentially like win a race condition where we just have something constantly looping, creating debug.log. So when the program erases debug.log, we create it before it has a chance to create it. But that is a really, really tough race to win. The best way I found to exploit this is to use the libfuse system. So to do that, we can look at it. If we look at the config and we have user allow other, then we'll be able to exploit it this way. Libfuse is like a file system in the user environment or user space or something like that. It just means like a virtual file system, right? The user allow other is going to allow other users to write to our file system. And if you use SSHFS, that's a common use case for using the Fuse file system. It lets you like do a mount over SSH. I don't like doing this just because I don't trust this target box. In order for SSHFS to work, we'd have to open up SSH on our box and let this box log into it, which that just does not sound like a good idea to me. I spent a lot of time looking at just various libfuse things, but I had troubles getting it compiled on my box and having it working on the target. Theoretically, you should be able to use like libfuse ext2 and then create like a ext2 file system on a file and then mount that. The other things I tried was like zip files and ISOs, right? But whenever I mounted these with libfuse, it was read only and I couldn't make it read write. But going back to where I had a lot of trouble statically compiling a bunch of Fuse things, I decided, you know what, I'm going to search Go. And if I search Go Fuse, we have a bunch of bindings for this. And I picked Go because everything in Go is going to be statically compiled. If I can compile it on my box, it's going to work on my target. So that's great. And looking at it, Go Fuse had examples. And on this page, the example was zipfs. I tried this, but that's where it was read only, and that wasn't good. But while I was in this example directory, I saw other things that just didn't make the documentation, specifically memfs. This is going to create a in-file memory file system, and that's going to be what we use. So I'm going to clone this repository. So we can do, let's do this, git clone, and then go into Go Fuse, Examples, memfs. And there's going to be one small change we have to make. I actually won't make it first. We'll do that after. So we'll just go build this. Okay. We can show it working. So if I do make dir output, I'm going to execute memfs, and we give it the directory, and then where we want it to write to. This is going to be, I'll call it log. So it has mounted that. Now, if I go into Go Fuse, Examples, memfs, if I go into output and we echo, please subscribe to text, it looks like that's there, right? It's also in log 1. We have please subscribe. So the memfs is always just going to write the contents of files into these files. So let's do this, and then fuse mount -u to unmount it. Output. There we go. So I'm going to copy this over to the host. So let's do Python 3 HTTP server. We can do a wget 10.10.14.8 8000 memfs to download it. And then let us, let's see, make dir output. Before we go in there, let's execute it. chmod +x memfs output, and I'll call this pwn. So we have mounted that. So if I go into this output directory, and then we have to do the sudo. So we'll copy this, run it. We get a permission denied. And that's because the actual application that we have isn't allowing other users to write to or mount. Let's unmount this. -u output. We have to get out of the directory. And what I did when I was going in here, go main.go, I was looking at what other mount options there were. And then right off the top, I saw allow other. So if we compile this with allow other set to true, and then we mount it. So let's do go build. The wget again. I'm going to delete the old one. I would call it memfs old 10.10.14.8 8000 memfs. We're going to run this again after we make it executable. Okay. And what do we want to do? Go into output, run that sudo. And now when we go out and we look at pwn, we have the contents of the debug log. So it's going to initialize the logger, it reads it, and that prints out the master token that we used. So if we look at this master token and we go, do I still have Postman up? I closed Postman, shoot. Let's see. I don't have it up anymore to quickly enumerate this. Let's see. We can close out this. Let's unmount this. We have already out. That's not where I was. Okay, this is what I wanted. Internal specs, no. I forget what it was called. Resultant ACL. This is it. Okay, so let's export history, grep, export. We want the vault token. That's not the right clipboard. There it is. When we read this, we're just root. So we can do anything we want. So if we use this token, and what was the other one? Was it admin OTP role? Where do we list roles? It was list roles, admin OTP role, change our vault token. You can set it to root. And now we should be able to SSH into the box. 10, 10, 11, 254. Put in this password, and we're root. So hope you guys enjoyed that. And that's pretty much going to be the video. So take care, and I'll see you all next time.